Hi everyone, in this video we will revisit something we've seen earlier, which is Green's theorem, and we will see if there's a way to rewrite it using the vector notation. So what does Green's theorem relate? If you recall, it relates line integrals with double integrals of a certain kind. So for example, if I have a vector field in 2 dimension, pi plus qj, then the line integral which is p dx plus q dy, we can regard f as a vector field in R3 with a j component 0. So which is saying that you can think of this as pi plus qj plus 0 k cap. When we do that, we can write down what the curl of f would be. So curl of f, which is from this section where we learned about curl, is going to be del x, del y, del z again, always, where we have a p, a q, and this is 0. So which means when you do your I cap, right, you're going to have a 0 and del z of q, which is 0 because that's a y component. And when you work everything out, the only things that will remain are the k cap things, which is del q over del x minus del p over del y. And if you remember or recall, this is very similar to an expression that we had in Green's theorem, right? Now, if I take a dot product of this with k cap, then this is del q over del x minus del p over del y, k cap dot k cap, which is just 1 because dot product of parallel vectors is 1 and their magnitudes are 1. So this becomes this expression del q over del x minus del p over del y, which is, recall, what we have in Green's theorem. So a version of the Green theorem here can be rewritten as that the line integral of a vector field f, which can be written in its dot product with its tangential form, becomes the double integral of the curl of f dotted with k cap, this should be a cap, dA. So this becomes your this is your tangential form, because we're using the tangent vector here. And there's also a normal version of this, and not normal version of this, instead of curl you have the divergence. So once again, both of these operations, curl and divergence, come into play for these rephrasing of the Green's theorem. So that brings us to the end of this section, and there will be other videos for the following section. Thanks everyone.